since I forgot to record yesterday. But you were all here, so was Wayne. The point 2, -3, if I'm ever moving a point, quiet please. If I'm moving a coordinate or a point, I will always use mapping, it's easiest. If I'm moving a graph is just a whole bunch of points and coordinates, yes? Then I'll use mapping. Okay? To move one coordinate or a whole bunch of coordinates, which would be a graph, you use mapping. It's the fastest way. I know right now +2 on the x and +3 on the y. Why am I showing mapping? Because we're preparing for not today. Yes? Okay. So the point 2, -3 lies on the graph of y equals f of x. State the coordinates of the image of the point under the following transformations. Remember, whenever you move a single point or a lot of points, graph, use mapping. So our goal first always is we have to have two things. We have to have it in y equals and a 1 in front of the x. Okay? We're going to have 1 in front of the x all day today, for the most part today. But we're still checking for it because we're preparing for later on too. So I'm going to subtract 8 to move it over. So I have y equals f of x minus 8. And then I always go, I'm doing this because I can't see my whole page. You can, I can. So mapping words equation. Yeah? Okay. Is that 8 with the x or is it with the y? It's with the y because this is with the x. The x is a 1 in front of it. That's all that's affecting the x, which means nothingness, right? So this means it's a vertical translation, 8 units, what? Down. So we're going to use mapping. X, y becomes, x stays the same because nothing happened to it. Look, it's just an x. And now I need to move my y coordinate 8 down. What am I going to do to it? Subtract 8. Because mapping and words are in a heart. They mean the same thing. So if I say 8 down, I move 8 down, which is -8. Yeah? Then I apply my coordinate into it. So I go 2, this is my original, 2 and -3 becomes 2, -3 minus 8, which becomes 2, -11. Which I know people could do in their heads. Cool. But we're practicing properly for later. And by later, I mean in 2 days. All right. B, what should we do? Add the 5 over, and we already have the 1 in front of our x, so that's good. So our words are going to be a vertical translation, 5 units what? Up. And this is an equation to words. So our x's be crazy, they're going to flip, right? X's be crazy. So x minus 7 is going to actually be a horizontal translation, 7 units to the right. Okay, so I want to move 7 units right, so what do I have to do to my coordinates to get it to go 7 right? Add 7 and 5 up. Add 5. Words, mapping, same, right? They're in a heart. Same. Bless you. Bless you. So we use 2 and -3. The question of the day. 2 plus 7, comma, -3 plus 5. And we get 9 and 2. Right? Okay, so I can give you an equation, ask for words and mapping. I can give you words and ask for mapping and equation. I can give you mapping and ask for words or equation. I can interchangeably move and do any of them I want. Okay? And then also domain and range and stuff involved too. So this one says, write the equation of the image. So the moved equation, the original equation they're giving us is y equals f of x. So nothing is on it, which is cool. Sometimes they'll give us an equation which already has been transformed, and we have to transform it, which is more. And mapping notation for each transformation. Write the equation of the image of y equals f of x and mapping notation for each transformation and the mapping notation. So just in case you didn't know you need to do the mapping notation, I wrote it twice, it seems. Super important to do and the mapping notation. You only have to do it once. I don't know. So I want the equation and the mapping. So we'll do the first one together. So equation, I want Should I do equation first if they're giving me words, or mapping first if they give me words? Which one would be easier to do first? Mapping. Words and mapping in a heart. Same, right? So, vertical translation, 3 units up. Does that apply to the X or the Y? The Y. So, I need to go Y plus 3. Horizontal translation, 4 units right. What does that affect? X or Y? And go to the right. X plus 4. Right? Correct? Can't use right. Okay. Then we go to words. Or sorry, words are given to us. Now we go to equation. So we go Y equals F. I want to go 3 up. So I get a plus 3 at the back because Y's are always the same. Y's are the best. Yes? We're going from now words to equation. I'm crossing over the equal sign. So what's going to happen to my X's? Switch. There we go over that equal sign. So if I'm doing X plus 4 or X or 4 units right, what's this going to be? X minus 4. Exactly. You try B. So our mapping, horizontal translation, M units right. Mapping in words, same. So I'm going to go M units right. I'm going to have to add M. Vertical translation, P units down. I'm going to have to what? Subtract P. When I go to the equation, I'm going from words to equation or mapping to equation. My X's be crazy, so they're going to flip. So I'm going to get, instead of X plus M or M to the right, I'm actually going to get X minus M. Can you see how it could be slightly confusing as to when you keep, when you switch, when you, because it kind of looks the same, but they're totally not the same. So if you keep in your head words and mapping, same, equation not, just for X's, they flip. It makes it easier because when you're stuck and you're like, oh, do I flip it or keep it? Go to your little diagram. If it's in the heart, you don't. If it goes across the arrow, you do. Yeah? And with Y's, never do it. If you ever do it, you're just wrong. So stop. Okay? And then I have minus P, I have P down, and I have minus P, right? Same thing. Okay, then flip over. Okay, so I get it, paying attention. I get that you can do this without mapping. Let's just acknowledge that. Let's get to that. Yes, you can. Very proud of you. Very proud. Don't. The laziness inside you might try, like, oh, what do they call it? Your whatever thoughts. Intrusive thoughts may want you to not map, but you say no intrusive thoughts. She said to map, so I will. Don't let them win today. Do not let them win. Okay. So this is our equation. We still need to move our minus 2 over. What is our transformation? Vertical translation. What? Vertical translation. 2 units down. Now we're going from equation to word, so what's going to happen to our X's? It's going to go over the arrow, so they're going to flip. So it's a horizontal, bless you, translation. 3 units what? Now, if we go from equation to mapping, our X's are going to switch, yes? But if we take the words we just found and went to mapping, our X's would stay the same, correct? So it depends on which one you look at, whether you're going to keep it or not when you do mapping. So I'm going to use words because they're the same thing. So it's a vertical translation 2 down, so I'm going to have to go Y minus 2. And it's a horizontal translation 3 left, so I'm going to go X minus 3. Now I need to put all the coordinates from that graph onto this one, and I'm going to show mapping, even if your heart doesn't want to. Okay, your heart doesn't have to be in it, you just need to do it. 1, 2, 3, 4, 5, 6, negative 7, and 2 is my one coordinate. I put it in brackets so I show its coordinate. 1, 2, 3, 4, negative 5, and 2. 1, 2, 3, negative 3, and 1, 2, 3, 4, negative 4. 2 and 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 1, 2, 3, 4, 4, and negative 4. Yeah? So just pulled the coordinates off of it. So if I do one coordinate, I use mapping. If I do numerous coordinates, I do mapping. So now I'm going to show my mapping to it. So I plug negative 7 in for x and 2 in for y. So I go negative 7 minus 3, comma, 2 minus 2. And my new coordinate is negative 10, comma, 0. I'm going to use a different color. So this is 7, 8, 9. We'll visualize this is 10. So it would be here. Now guys, what I need you to do is I need you to do one coordinate, bold it, yes? Next coordinate, like so not random coordinates. The next coordinate to it, bold it, connect them. Because what happens is people will find like 5 coordinates, and they put them on, and the coordinates are all correct, and then you guys like etch a sketch wrong. And you're like, I want this one with this one, and then this one and this one, and that one over here. And that's bad. It happens all the time. So one coordinate, then do the next one. So we get negative 5 minus 3, comma, 2 minus 2. And so then this one's at negative 8 and 0. Fold it, connect it. Like I said, this one's more obvious because there's not a lot of transformations, but there will be. So finish off B, and then I want you to do, example 6. I don't know why I was so scrolling. B and then example. So we put this one in. It's mapping. We get negative 3 minus 3, comma, negative 4 minus 2. And we get negative 6 minus 6. 1, 2, 3, 4, 5, 6. Awesome count. Then connect, right? And then we go, bless you, 2 minus 3, 6 minus 2, and we get negative 1 and 4. Connect it. And then our last one. 1 and negative 6. And we connect it. Okay? The next one I told you to do, state the coordinates of the image of the point negative 3, 5 on the graph of y equals f of x under the transformations described by the mapping below. Yep.
Would we be given that type of question in test format on the exam?
Could be. In a written response to draw it. It'll just have way more transformations than just started writing that out. Yeah. Then, or left and up. Then just left and a down. I don't even know what I'm saying. Then describe the transformations and state the new equation. Okay. So, if I give you a coordinate and I give you mapping, that's the easiest question ever because I literally gave you the way to do it. Correct? So more often than not, if I'm asking you to move coordinates, you're probably not going to get the mapping. You might get the word or the equation and have to get the mapping. So let's do that first. So we go negative 3, 5 becomes negative 3 minus 7, comma 5 plus 4. So it becomes negative 10 and 9. Now, we're going from mapping to words. Mapping in words is in a heart. So my mapping and my words will be same, right? X is the same, Y is the same. Mapping to words in a heart. So if I'm taking an X coordinate and I'm subtracting 7 from it, X coordinate subtracting 7, it's going 7 what? Left. So it's a horizontal translation. Seven units left. And then if I add 4, it's a vertical translation. Four units up. The next one I'm going to apply negative 3, 5 as my original to these. Negative 3 minus 6, 6 left. 5 plus 1, 1 up. So I'm going to get negative 9 and 6. Now once again I'm doing words of mapping. Same, right? X's not be crazy when they're in that heart. So if I'm going x minus 6, that's a horizontal translation, 6 units left. And a vertical translation, 1 unit up. Okay, let's look at example 7. It's a little bit different. Paying attention? So, the other equations I gave you had that little f in it, correct? That f just meant that that is another way of saying the transformation or showing the mapping is with that equation, correct? You cannot type that f equation into your calculator. There's no little f you can input to do it. It's just telling you how you would move any function. So technically, when they give you the equation with an f, I could give you any function. I can give you a quadratic function, a linear function, a log function, a trig function, and give you that same transformation, and you can move all those graphs the same way. 3 up, 2 down, whatever it may be. Okay? That's what it is with an f. But look at these. This here is actually a quartic function. It's x to the 4, which we will be dealing with. Is there an f in this one? No. So could I actually look at what that one looks like and put it in my calculator? Sure. That is your difference. It has an f in it. It's transformations that you can apply to any function in the world, correct? This one, if I add that 3 over, is that with the x? The x is here. Is that with the x? No. So that's a vertical translation 3 units up to this quartic function, and only this quartic function, because I'm applying it to the quartic function, correct? I could put both equations into my calculator and look at what happens. So, describe how the graph of the second function compares to the graph of the first. Notice the equations do not have an f in them. You can put these in your calculator. You have to state how the second equation has changed from the original. Then give mapping. So if I do my words first, it's a vertical translation. It's y, so nothing ever changes. Vertical translation. 3 units up. Then my mapping would be x, y. Does anything happen to my x? No, it has a 1 in front of it. Nothing's happening. So x, and then I have to go 3 up. So y plus 3, because mapping and words are the same. Correct? Okay. When I look at b, a lot of people first try and distribute it. Don't do that. For b. We want to talk about how it changed. Okay? So the original is y equals 6x minus 3. It's a linear graph. Now it's y equals 6, x minus 1 minus 3. So what is the same? The 6 is the same, so has that changed? The negative minus 3 is the same, so has that changed? The only thing that changed is the x minus 1. Right? So we're going from equation to words and mapping, correct? So we're going over the equal sign. So what's going to happen with my x? Over the arrow, double-head arrow. What's going to happen to my x? It's going to switch. So it says x minus 1, which actually means horizontal translation 1 unit to the right. And then my mapping is the same as my words, so I get x, y becomes x plus 1, because that's how I move right. Y. Then flip over. 2 more questions on the back. Go. So on the next page, there's 2 more. Try them out. Remember, you're only commenting about what changed. If it's with the x, it affects the x. If not, it affects the y. For this first one, what do I have to do first? Move the 2. Yeah, get into y equals. And have a 1 in front of my x, which I already do. Yes? Then I compare what's different. This one has absolutely nothing happening to it, so both of these affect it, correct? Now, if we go from equation to words and mapping, which is what we're doing, our x's switch because they'd be crazy, right? So we have a horizontal translation, 6 units right. Which means my mapping would be xy becomes x plus 6 because I have to move 6 to the right. Correct? Mapping in words, same. Then vertical translation, 2 units up, and then I go y plus 2 because y's never change. They're the greatest things ever. And plus 2, you go up, mapping it would go up, in the equation it would go plus, right? Now this one, it's actually a rational with a radical. It's quite crazy. The 3's are the same, so the only thing that changes is this x plus 1, and it's currently with the x, yes? And then this is sitting at the back, so it affects the y. It only affects the x if it's actually in with the x. If it's not beside the x, it affects the y. It's very easy to figure out. So, we have a horizontal translation. One unit what? Left. Because equation, 2 words and mapping, x is switch. If I go to my mapping, xy becomes x minus 1, because that's go left. 5. Then I have a vertical translation. Five units what? Okay, this one says, write the equation of the image of the function, then give the mapping notation. We'll do the first one together. So this is different. If it was just like y equals f, if you had to go transform form equation, then you would just put it in and just straight up. This one, though, you actually are given an equation. Your original is not f of x. Do you see this? Your original is x squared, so you have to apply it. The other ones you were doing, your original was f of x. You just filled it in. Here, that would be in every function in the world. Now they're giving me a specific function. It's a quadratic. Now they want, after a horizontal translation, 3 to the right. So we're going from words to what? Equation. Correct? So what's going to happen to this? 3 units right. It's going to go in as what? X minus 3. In for the x. So I'm going to go x minus 3. I swap out that x, this replacement notation. I throw the x away, replace it, and then I still have to put that squared. Correct? Now, if I go from this is how it depends. If I go from words to mapping, which is what they gave me, words to mapping is same, correct? So words is 3 units right. So I'm going to go x, y. 3 units right means I have to add 3. Y. You try B, C, and then see if you can figure these ones out. B, C. Okay, so for this one, it says y equals 10 to the x, which is an exponential function, which we'll be doing this year as well. After vertical translation 2 units up, Horizontal translation, 5 units left. So if we're going from words to equation, our x's are going to flip. So we're going to get y equals 10 to the x plus 2 is back here because it's not with the x. And then 5 units left, I need to go x plus 5 because it's always the opposite. In an equation, it stays with the x. Then my mapping and words be the same. They're in a heart. So if I want to go 2 units up, I'm going to go y plus 2. If I want to go 5 units left, I'm going to go x minus 5. I do as I say. All right. This one is a radical function, which we're also dealing with this year. After a horizontal translation of 4 units left and a vertical translation 3 units down. So I'm going to go y equals square root. It's like having a bracket around x. The square root would be the bracket. I need to go 4 left. So I'm going to go x plus 4 because words to equation, the x's flip. Vertical translation 3 down minus 3. My mapping, same as my words. So I need to go 4 to the left. So I'm going to go x minus 4. I need to go 3 down and go y minus 3. Do you see how easy it is to flip and not flip when you should flip and shouldn't flip? All the answers to the oopsies will be there. So we need to know our stuff backwards and forwards, no errors, okay? And I tell you, the words in mapping, heart, and equation do help. Because if you cross over that arrow, your x's switch. If you stay within, they don't. This one, the function represented by the thick line is a transformation of the function represented by the thin. So thin's original, thick is the transformed. Write an equation for each function. So we're going to label this y equals f of x as our original. What happened to it? It went 1, 2, 3, 4 what? 4 down. And then 1, 2 what? 2 right. So we're going from words to equation. Are we going over the arrow? Yes. So our x's are going to switch. So our original is y equals f of x. So we're going to get y equals f. I need to go 2 right. So words to equation, my x is flipped. So how do I get 2 right? X minus 2. And my y's are always just good. Minus 4. Nope, because I didn't use y equals absolute value of x. My original was y equals f of x. My original wasn't y equals absolute value of x. Had you said y equals absolute value of x, then you would have to have absolute value of x's. You'd have y equals absolute value x minus 2 minus 4. Which depends on what the original is. You wouldn't be wrong because I didn't give you an original until now. This would be y equals f of x. See, like this one you have to do transform quadratic. And you transform quadratic if you did it that way. This one is y equals f of x. I go 1, 2, 3, 4, 5 down. Then 1, 2, 3 right. So I would get y equals f. How do I go 3 right in the equation? X minus 3. And then 5 down is just minus 5. Then we're going to flip over. Okay. So here we have y equals square root x as a radical function. What vertical translation would be applied to y equals root x? So the translating image passes through this. So this is the transformed coordinate. And they're asking for the vertical translation. So if only a vertical translation is happening, what value is staying the same? The 16, right? So technically, we have 16 comma something becomes 16.7. And this is our OG, our original. Yeah? How do I know what the y is on the OG? What? Look at it on the radical graph. Yeah, so we could just plug it into the equation, yeah? So we know x, so we could go y equals root 16 and get what y is on the original, correct? Because you can input a y, you input an x, get out a y for the original. So y equals what? 4. So from here to here, what am I doing? Adding 3. So what is that? They want the translation. Vertical translation. Three units what? Up. How is B different? B has what? Horizontal translation this time. So what's staying the same? The Y. So this is an 8. Becomes 17/8. So now I have to solve for the X, correct? So I'm going to get Y equals X squared, Y equals root X, sorry. So 8 equals root X. How do I get root X to get you some X? Square both sides. So X equals 64. So what do we do to get from here to here? You subtract what? Pardon? So I'm subtracting 47 in mapping. What?
Could you not just do y equals root x plus h and then substitute x and y?
Root x plus h.
H is under the root.
But you're putting what in?
X and y.
What x and what y?
Y is 8 and x is 17.
So if you put that into your original and you're solving for the h that you're trying to find in the middle, what did you get?
47.
It only works in this instance because we have only one transformation happening. Because they specified specifically, right? It's also the only reason why we can do this method as well, because there's only one transformation happening. So if there was more than one, we would have to move more things. Indirectly, mine wouldn't work and neither would yours. It works because you're just solving for h. Yeah. You're doing it a different way. Because, and this is the key thing for yours, because the original had no transformations. So if the original wasn't like y equals root x, if it was like y equals root x plus 2, you have to encompass that 2 in with the h. Yep, then it'd be totally fine. So we have a horizontal translation. 47 units what? Okay. This is a summary of different forms. It just goes through it for you. Just to remind you what it is. Your homework I printed.